Okay, we're going to look at the law of sines and the law of cosines. And these are some rules that you can use to find missing sides and missing angles for any triangle. So it's kind of has the feel of right triangle trig, sort of, but it kind of takes it a little further. And you can use this with any triangle. So it makes it kind of nice. And the law that you're going to use, it depends on what sides and angles you have and what you need to find. And the two laws complement each other very well, and together you can solve pretty much any sort of problem involving triangles. So they're really kind of neat. They work together very well. So let me first introduce the laws, and then we're going to try to solve these three triangle problems I have here. And we'll need to know which law to use. And I'm going to start with the law of cosines, because for me this is really easy to remember. It's kind of easy to recognize here. Basically, if you're given two sides, and we'll call those A and B, and you're given the angle between them, then you can always find that opposite side. Okay? And the relationship is this opposite side. That squared is equal to a squared plus b squared minus 2 times a times b times the cosine of that angle. Okay, so it's kind of weird here, but one way I think of it is this almost looks like the Pythagorean theorem, doesn't it? See that? And so if we thought of these as being the legs of a right triangle, right, and that the hypotenuse, then what you're saying is kind of like the Pythagorean theorem. But since it's not a right triangle, you have this extra added term, which is you're subtracting 2 times a times b times cosine of that angle there. Okay? And otherwise, it's that you have that relationship, sort of like the Pythagorean theorem, but not. But notice, even if this were 90 degrees, then cosine of 90 degrees would be 0, and that would go away. So if that were 90 degrees, it does reduce down to the Pythagorean theorem. Okay? So that's kind of neat, kind of interesting. The other thing is you can use this to find the angle too. If you're given all three sides, you can find the angle. So the examples where you use this is if you're given a side angle side or a side side and a side. Okay. The law of sines is basically saying, okay, if you have a triangle, then the sine of the angle, the ratio of the sine of the angle to the opposite side is the same for all three angles. Okay, and that kind of makes sense because the wider the angle, the bigger the side, the ratios are going to be the same. If it's a really small angle, smaller the side. And so the ratio of all three, of the sine of each angle to the opposite side is the same for all three. So the sine of A to A is equal to the sine of B to its opposite side, the sine of C to its opposite side. And you can use these to solve problems that involve an angle, and a side, so two angles and a not included side, or a side that's between two angles, an angle, side, angle, or if you have two sides and an angle, you can find the other information as well, on either the other side or even another angle. Okay, so those are the two laws here, and so let's think about which law we would use. Okay, and let me tell you, I didn't explain how you would use this. The idea here is you're going to end up setting up a proportion, so you're going to be given at least you have to use the law of sines, you have to have at least an angle and its opposite side, and that'll set up one ratio, and then you're given one of these two here, and you can find the missing one. Okay, so if you're given an angle and its opposite side, plus you're given this angle, then what you can do is find the opposite side. Okay, so let's just see this triangle here. It's saying it's giving me these two sides. The angle between them is 78 degrees. It wants me to find this opposite side. So can you see which law that you would use? Okay? In this case, you would use the law of cosines, because you're really given a side, two sides, and the included angle. Side, angle, side. And then I want to find the opposite side. Okay? So let's do that here and see if we can find c squared. Or see if we can find the opposite side, c. Okay? So maybe I'll write all this. Maybe I'll just do this. I'll do c squared is equal to, it's going to be 10. These are like the two legs. 10 squared plus 7 squared, and then I have to subtract 2 times 10 times 7, and then the cosine of 78 degrees. Okay? And so what I do then is, to find the opposite side, I just put all of this into my calculator. So that would be 10 squared plus 7 squared minus 2 times 10 times 7 times cosine of 78 degrees. Okay? And this equals that 119.89. Okay? But that c squared is equal to that 119.89 whatever. It's not, so that's not the opposite side. So to get the opposite side, you got to take the square root of that. Just like the Pythagorean theorem. And of course, you're only interested in the positive square root. So I'm going to raise that to the 0.5 power. And I get that c is approximately, I'll round to the nearest whole number. So c would be approximately 11 feet. Or that x in this case. X is equal to approximately equal to 11 feet. Okay. Now one thing I didn't mention here, I had changed this to degrees, but we've been using this in radians, so your calculator is probably in radians, and if you went and did this problem, you could get a negative number or a really big number, something that doesn't make any sense at all. And this can be a real frustration, okay? It can really mess students up, especially during a test or something, if it switches from radians to degrees or something, and you've been doing it in radians, but you forget to switch to the other one. So you do got to go through, switch this to degrees before you do these sort of problems, okay? Which it is now in degrees. Okay, so now what about this one? What do you think we would use? Looks like I'm given an angle and an angle on the side between the two angles. So this would be like the angle side angle, okay? And so this really involves, so I'm going to use the law of sines, and this really involves setting up a proportion, and I actually need an angle and the opposite side for one of the ratios, okay? So I'm not given this angle, but I can find it, right? Because they all add up to 180 degrees. So I got to take 180 minus 17 minus 42, and I'm given that this is 121 degrees. Okay, so this will be the one that I set up. So I got sine of 121 degrees is to 20 as, and I want to find this shorter side here, so as the sine of 17 is to x. 17 degrees is to x. And this is pretty much like solving a proportion. So I'd get like the sine of 21, or I'm sorry, it's 121 times x is equal to 20 times the sine of 17 degrees, right? And then I can divide both sides by the sine of 121 degrees. And so I get that x is equal to all of that, like 20 sine of 17 degrees over sine of 121 degrees. So let's see what it's equal to. Okay, so I get 20 times sine of 17 divided by sine of 121. And I get like 6.8, approximately 6.8. And that is quite believable here, right? Approximately 6.8. That would be the answer there. Okay? So very good. I use law of cosines. So this one, I want to find this angle. So I'm given the three sides of the triangle. I want to find that angle. So clearly I'm going to need the law of cosines, right? Where you have side, side, side. Okay? There's no way I could set up a proportion of the sine of any angle and the opposite side. So this is a law of cosines. And let me actually give you... so what you basically do is you put the A, the B, and the C all in there, and then you solve for that cosine theta, right? So what I'm going to do is I'm going to give you this. I'm going to tell you that the cosine of theta is equal to, so basically you're taking that C squared, you're moving the A squared and the B squared to the other side, right? And then you're dividing by that negative 2AB. And so you can just think of this as a second rule, that the cosine of theta is equal to all that. And then that helps you here. The cosine theta is equal to, so this is my theta, so this is my C, and that's my A and my B, right? So it'd be 8 squared minus 15 squared minus 20 squared, all over a negative 2 times, this is A and B, so 15 times 20, okay? And then I'll get some number here, and then I just got to take the inverse cosine. This isn't like a basic trig equation, right? Because the angle will be the one between 0 and 180 degrees, right? You want that angle. And so you only need to do the inverse cosine of this. So you could actually have theta here is equal to the inverse cosine of all that, if you wanted to. But that's okay, we'll do this. So make sure here, when you put this in your calculator, you're using parentheses. So 8 squared minus 15 squared minus 20 squared. And then I'm going to divide that, and then the bottom needs to be in parentheses. Negative 2 times 15 times 20. And then I get like this. It's like, oh, that turned out nice. 0.935. Okay, that's amazing that it did that. It doesn't always come out like that. Okay, so my theta then is equal to cosine inverse of 0.935. So I'm going to do the cosine inverse, and I'm going to do the answer there. Put in the answer. The answer, if you want to put in the answer of the line above into your problem, you use this A and S, second, and it's right above the negative sign. And so what I get here is approximately like 20.77 degrees or something. And so that would be the angle. Okay, right there. Okay, so you can then use this for lots of different things. You can solve problems, real-world problems that involve a triangle of somehow. So very similar to like a right triangle, type problems. You can also use this to set up functions that you're going to then use in to model a situation, and we'll see that probably later on. But on this assignment, it's just going to give you kind of a basic triangle, and it's going to want you to find the missing side. So for now, that should be good. That's the law of sines and the law of cosines. One thing I didn't mention that I should mention too is that this case here, when you're given a side-side angle, and you're going to use that to find a missing angle, or you're going to use that to find a missing angle or a missing side, that's an ambiguous case. In other words, you might not get a solution, you might get one solution, or you might get two solutions. And it just depends on, as you're solving the sine equation, because in sine, between 0 and 180, there's two solutions. And if both of those make sense as in a triangle, then it'll actually create it could create more than one solution, or you might get a situation where you don't even you can't even solve it, that your sine equation is going to equal something greater than 1. I wouldn't worry about it now. If it pops up, if it shows up later on, I can talk a little bit more about it then. Okay, but on this homework, this here is just fine.